welcome to my channel. Now let us discuss the structure of atom. Let us discuss the charges present in the map. Now let us start with a small experiment. See, this is the plastic comb in my hand, and of course my hair is dry hair. Dry hair means after taking bath. The hair after taking bath is referred as dry hair. Now I am combing my hair, dry hair, with a plastic comb. Similarly, when ebonite rod is rubbed on flannel cloth, now what happens? On small pieces of paper, the small pieces of paper are attracted towards the comb. What happened here? When the plastic comb is rubbed on dry hair, the comb gets charge. It may be either positive charge or negative charge. When the charged comb is brought near the small pieces of paper, the small pieces of paper, as their weight is negligible, because of the charge present on the comb, the small pieces of charge are attracted towards the comb. So, if the plastic comb gets, say, positive charge, oppositely negative charge is established on hair. Thank you. John Dalton stated in his atomic theory that the matter is made of tiniest particles called atoms. Atom is indivisible, that is, atom cannot be divided into further smaller particles. According to modern concepts of atom, atom is divisible and is shown from the discharge tube experiments. As per modern concept, atom has elementary or subatomic or fundamental particles, that is electron, protons and neutrons. Now let us know about discharge tube. Discharge tube is a hard glass tube having a side tube, and to this side tube a vacuum pump is attached. The purpose of this vacuum pump is to remove the air inside the discharge tube so that the pressure can be minimized. Now, two metallic plates are arranged on either side of the discharge tube, which are connected to the terminals of a battery externally. This is the battery and this is the circuit. Now, this is cathode. The metallic plate which is connected to the negative terminal of the battery is referred as cathode, and the plate which is connected to the positive terminal of the battery is referred as anode. Cathode and anode. And the surface of anode is coated with zinc sulfide. The pressure inside the tube, when it is decreased to 0.01 mm, and of course voltage is applied around 10,000 volts. Under these conditions, a kind of rays travel from cathode to anode. On anode, the spots of light, here the spots of light are formed, which are referred as scintillations. Why these spots of light are formed? Because certain rays travel from cathode to anode. These rays fall on the zinc sulfide coating and the spots of lights, that is scintillations, are produced. These rays are referred as cathode rays. Therefore, the cathode rays are made of negatively charged particles called electrons. Now let us see the Thomson's model of atom. Thomson thought that when negatively charged electrons are present in atom, there must be positive charge also, because atom does not show any charge outside. How these positive and negative charges are present in the atom? The arrangement of different particles in the atom is referred as model of atom. Thomson proposed that watermelon model to atom. According to him, atom is full of positive charge and negatively charged electrons embedded in all along the positive charge, and is just like a Christmas cake in which plum seeds are spread in it. Therefore, this model is also referred as plum pudding model. See here, this is a plum cake. All this duff is compared with positive charge, and here the plum seeds in the black color, they are like electrons. This is also referred as watermelon model, in which positive charge is like a fibrous material in watermelon, and electrons are like seeds distributed in the watermelon. And of course, this is the atomic model in comparison with the watermelon. J.A. Thomson, a British physicist, was born in Chatham Hill, a suburb of Manchester, on December 18, 1856. He was awarded the Nobel Prize in Physics in 1906 for his work on discovery of electrons, which was the great achievement. He directed the Cavendish Laboratory at Cambridge for 35 years, and 7 of his research assistants subsequently won Nobel Prizes. As per Thomson's model, atom is full of positively charged sphere and electrons are embedded in it. The negative and positive charges are equal in magnitude, so the atom as a whole is electrically neutral. Now let us see the merits and demerits in Thomson's model. The merits in Thomson's model, it rightly stated that atom is electrically neutral because the magnitudes of both the charges are same as mentioned here. The demerits, static electrons. Static electrons means, according to this model, as we compared the atom with watermelon or plum pudding, electrons do not have any motion. Therefore, we refer it as static electrons. Static electrons in the positive charge destroys the atom, which is not happening. Rutherford tried to prove the Thomson's model and hence conducted the alpha ray scattering experiment. Now let us see the Rutherford's alpha ray scattering experiment. Rutherford in his experiment made alpha particles to bombard the gold foil. An alpha particle is a nucleus of helium atom having 2 units of charge and 4 units of mass. As Thomson stated that atom is full of charge, positive charge, Rutherford expected that a massive and all the positive charged alpha particles deflect back. Rutherford's alpha ray scattering experiment. Let us have some previous knowledge. Helium is the lighter gas and it has atomic number is 2, mass number 4, which indicates that helium has 2 protons and 2 neutrons in its nucleus and it has 2 electrons. Suppose if these 2 electrons are removed, then this becomes the nucleus of the helium atom and it carries 2 units of positive charge due to the presence of 2 protons and it carries 4 units of mass due to the presence of 2 protons and 2 neutrons. So, such a nucleus of helium atom is alpha particles. Now, in this experimental setup, a small amount of radioactive substance like uranium is taken here in this lead block. This is lead block. So, this lead prevents the scattering of alpha particles in different directions because lead absorbs alpha particles. So, these alpha particles are passed through a small hole kept in this cavity and these alpha particles are made to fall on a very thin foil of gold. Thin gold foil of thickness 10 to the power minus 5 centimeters. Why only gold is used? Gold is highly malleable. It can be drawn into very thin sheets. A thickness of 10 to the power 5 centimeters is believed to have 1000 layers of atoms in such a thin sheet. Not only that, gold is highly inert. So, the alpha particles fall on this gold foil. They are penetrated through this gold foil. How do we know that they penetrated? Here, a setup is kept here. This is a fluorescent screen. A circular fluorescent screen is kept which covers the gold foil. So, the alpha particles penetrated. Now, here Rutherford made some observations. By observing the scintillations formed on this fluorescent screen by a microscope. So most of the alpha particles penetrated and fell on the same spot, say that is A, which may be referred as a usual spot. Few alpha particles deflected through certain angle as scintillations are observed at different places on this circular fluorescent screen. And 1 or 2 alpha particles out of 10,000 or 20,000 particles it deflected through 180 degrees. That means almost the alpha particle penetrated back. So these observations, from these observations, what can we understand? So as most of the alpha particles penetrated through gold foil, that is most of the scintillations are made at the same spot. It may be concluded that the gold foil, that is, the gold foil is full of atoms and the atom is almost empty. Since atom is empty, most of the alpha particles could penetrate through the foil. Since few scintillations are made at different points, that is, few alpha particles are deflected. Deflected means they are repelled. They are repelled and of course they change their path. Why they are repelled? So you know that alpha particle carries a positive charge. Such a positively charged and massive alpha particle is repelled. We know that like charges repel each other. So since a positively charged alpha particle is repelled, means there should be some positive charge present in the atoms of gold sheet. And of course that can be verified by this observation also. Out of 10,000 or 20,000 alpha particles, only one deflected back. That means that alpha particle might have struck the positively charged particle present in the atom directly, therefore it reverted back. This is the schematic representation of Rutherford's alpha ray scattering experiment. And this is the schematic molecular view of the gold foil.
In 1910, Rutherford and his co-workers were studying the angles at which alpha particles were scattered as they passed through a thin gold foil. Most of the alpha particles passed through undeflected. However, a few were found to be scattered at large angles, some even back in the direction from which they had come. This meant that they had collided with an object much more massive than the alpha particles themselves, yet so small that only a few alpha particles encountered them. This atomic level view shows what is happening. Most of the atom is occupied by the low mass electrons. The nucleus is small and massive. When an alpha particle encounters a nucleus, it is scattered at a large angle.
Rutherford's model of atom. Based on the observations made from alpha ray scattering experiment and conclusions drawn, Rutherford proposed his model of atom. According to the Rutherford's model of atom is mostly empty. Most of the mass of the atom is densely concentrated in extremely small region, and this very small portion of the atom is called nucleus. The nucleus is surrounded by electrons that move around the nucleus with very high speed in circular paths called orbits. Thus, Rutherford's model of atom resembles a solar system in which nucleus plays the role of sun and electrons that of revolving planets. Thus, this model is also called as nuclear model of atom. Electrons and nucleus are held together by electrostatic forces of attraction. Nucleus is very small when compared to that of atom. Atom has a size of 10 to the power minus 10 meters, whereas the nucleus has the size of 10 to the power minus 15 meters.